Okay, so in this video we're going to be looking at quadratic inequalities, and we're going to start off focusing on the skills. We're going to look at some applications and some exam questions later on as well. Now, it's worth noting that quadratic inequalities are also in the A-level syllabus, so if you're going to be doing A-level maths, this is definitely something to be paying attention to, and this kind of question would come up towards the end of the exam paper. So my first thing I want us to think about as we learn about this topic is how are these three following things going to be represented on the graph of y equals x squared minus x minus 6. So here is the graph of y equals x squared minus 6, which I've just taken a screenshot of from desmos.com. And I'm going to start off by thinking about when is this the case. So this thing, this x squared minus x minus 6, is the same as y. So we're really saying where on this graph is y equal to 0. So where on this graph is y equal to 0? Well, here is 2 points on this graph that have a y coordinate of 0. Okay, we are actually saying in those two places they have a y coordinate of 0, and those two blue dots are also known as the roots of the equation. Now for the next one, we're saying that this section here is y, right? That's what y is equal to. We're saying when is y greater than 0 on this graph? Well, this section that we have here, all of these coordinates have a y coordinate that is a greater than 0, that's positive. Down here, all of the y coordinates on the graph are less than 0, and we want the y coordinate to be greater than 0. So anything that is above this line here is greater than 0, and I'm going to now sketch in onto the graph. These sections are when it is greater than 0. Let's make that a little bit tidier. And it's important to notice that the x coordinates, when the y coordinates are greater than 0 here, are these ones. We are saying these ones right here, because on this point on the graph, the y coordinate is 7, it's positive, and the x coordinate is somewhere like, I don't know, about minus 3.2, minus 3.1. So these x coordinates will produce a y coordinate which is greater than 0. These x coordinates, minus 2 and 3, will produce a y coordinate that is actually equal to 0. So I'm going to do the last part of sketching on the graph, and then we're actually going to answer these questions that we've got here. So the last one, unsurprisingly, we're saying when are the y coordinates less than 0? Well, less than 0 is going to be below this graph. We're saying that the y coordinates are in the negative section. Anything that is going below the axis here is where the y coordinates will be negative. And the corresponding x coordinates for this section, all of this part here, the x coordinates are this inside section that we have here. So we've now been able to split up the graph in two ways. We've been able to split up the y parts of the graph, so the bits that are above, the bits that are on the line, and the bits that are below the line, which corresponds to the x parts of this middle section corresponds to the y parts being less than 0, the blue dots correspond to when it's equal to 0, and the green parts correspond to when it's greater than 0. So I guess we should have noticed at the beginning the reason why these roots are at minus 2 and minus 3 are because of the way that this factorizes. We can very quickly just say that this is going to factorize to an x minus 3 and an x plus 2, hence the roots being at 3 and minus 2. So when I answer this first one here, the solutions are going to be that x is equal to 3 and x is equal to minus 2. Now when we go to this next part and we're going to say about when it is corresponding to the being greater than 0, well, it looks like we're saying that these x sections here are where the graph is going to be greater than 0. So either x are these numbers greater than 3, and obviously this would just keep going on and on and on. So we're saying that x is greater than 3, or x is less than minus 2. And then for our last one that we've got here, for when it is less than 0, the x coordinates that correspond to that are in between minus 2 and 3. So we write the inequality in this particular way. So our answers are, for the first one, it's this. For the second one, it's both of these with the or. And for the third one, it is in between the 2, minus 2 and the 3. So let's have a look about what the way we would solve these quadratic inequalities. So the first thing that you need to do, if necessary, you rearrange it to a standard form that looks like this. You change the inequality sign to an equality sign. So you take any of these symbols and you just pretend it's an equal sign. And what you do is you solve it to find the roots, because that's what we needed here. We needed these roots so that it would help us figure out what all of these parts. You'll notice how these roots appear in the answers for these inequalities. Then what you do is to find the roots, you can either factorize it, you can complete the square, you can use the formula, you could even use a graph, which I haven't mentioned. Probably factorizing is the easiest one, but you can use these other things for finding the roots too. You then sketch the graph. It's either going to be this shape or this shape. The first shape that we've got over here, this is going to be when a is greater than 0, when it's a positive value, and this is when a is less than 0. In other words, if you have a negative here, it's going to be that upside down shape. And then you use this idea of writing the inequalities, remembering that if it's above the axis, that's saying that it's greater than 0, and below the axis is less than 0, just like we said on this graph here. So let's have a quick go at this one that we're going to do. We're going to try and solve this inequality that we have, and we're going to solve x squared plus 3x minus 10 equals 0. So if necessary, rearrange it to standard form. Well, it's not necessary, but what I am going to do is I'm going to change the inequality sign to an equality sign, just so I can figure out what this will look like as a graph. So I'm going to factorize this one, and it looks like it's going to factorize to an x plus 5 and an x minus 2. So now that I've got that, I can find out what the roots are. So the roots are going to be 2 and minus 5. So I can now draw a sketch. Now, I'm not going to be too bothered about this being to scale at all, but clearly one of the things is over to the left and one of the things is over to the right. So there's this root of minus 5 and this root of 2 that we've got here. So I've done number 1, done number 2, done number 3, I've sketched the graph. Now I'm just going to use this to write the inequalities. So I'm trying to think of when I want this to be greater than 0. So I'm talking about these branches here. I'm talking about the sections where I want it to be greater than 0. Let's go to the colour of green that I've been using. So this part and this part are going to be referring to these x coordinates and these x coordinates, which means it is going to be this section is where x is greater than 2, so I'm just going to write that in straight away. So x is greater than 2, or x is less than minus 5, which is corresponding to this second branch that we've got over here. Now the second question is asking us when it is less than or equal to 0. So less than or equal to 0, we're actually thinking about this part of it down here. And it's also going to include these roots. It's going to be this whole section, which is actually going to be the in-between of the minus 5 and the minus 2. So we're going to say that the x values are in between the minus 5 and 2, but because they're also allowed to be equal to 0, we're going to include those two. So that the solution to this inequality is that x is between minus 5 and 2. Now, just actually think about what's happening here. We're saying if x is a number between minus 5 and 2, let's pick a really easy one. 0 is in between minus 5 and 2. If you sub 0 in here, it should make the whole thing true. So 0 squared, which is 0, plus 3 times 0, which is 0, minus 10. Well, that's just minus 10 is less than or equal to 0. Good, that's correct, that one works. If we said that x was a value bigger than 2, let's say that x is, say, 10. 10 squared is 100, plus 3 times 10 is 30, that's 130. Minus 10 is 120. 120 is greater than 0. So these inequalities are actually saying, what are the conditions that make this writing in blue true? I'm going to just do one more example here, and well, kind of one pair of examples, and then you're going to have a go at these two. And I'm going to do a separate video of some further examples. So this one isn't currently in the best form, so we're going to try and take this and rearrange it so that it looks like it's in its standard form. And in fact, we can also do the first two steps. We can change the equality sign. We can do step 1 and step 2 at the same time. So I'm going to take my 2x squared minus 4x. I'm going to change it to equals 48. Now, you should notice that everything here can be divided by 2. So I'm going to divide it by 2. So I get x squared minus 2x. It's going to be a 24, and I'm also going to subtract that 24 over here. All we need to do now is think of two numbers that multiply to minus 24 and add to minus 2. So minus 24, that could be 12 and 2. I don't think that's going to be that good, so we can do 12 and 2. No, that's not going to work. We could do 6 and 4. 6 times 4. Oh yeah, that's probably going to work. We can do a plus 6. So we can do a minus 6 and a plus 4. So that's going to be an x minus 6 and an x plus 4 being equal to 0. Yeah, that's going to work out nicely. Now that I've got these roots, I can see that the roots are going to be 6 and minus 4. I can draw a quick sketch of the graph and help me figure out what's going on. Don't worry too much about what the graph looks like, it's just a visual tool. So we have 6 and minus 4. Now that we've got it written like this, we can see that this equation is the same as this one. Let's just continue with some of that rearranging that we have. It would be like a 2x squared minus 4x minus 48 is less than 0, x squared minus 2x minus 24 is less than 0. Okay, so we're talking about where it's all less than 0. If it's less than 0, we're referring to this part of the graph, which is the in-between. So the answer to this one, I'm going to just squeeze it in and highlight it, is going to be that x is between minus 4 and 6. Sorry, I've had to squeeze that in, but the answer is that it's in between the minus 4 and 6. This time it's doing the same kind of rearranging, apart from at the end it's going to be greater than or equal to 0 when you do that rearranging. So we're talking about these two branches that we have here and here. So we're talking about this part, which is greater than 6, and this part, which is less than minus 4. So we're going to say that x is greater than or equal to 6, or x is less than or equal to minus 4. It could be the or equal to sign because of this sign that we've got here. So again, I'll just highlight that answer to make it clear that this is the answer to the question. Okay, so here's your 10. I want you to solve these two that we've got here. I've made them quite easy, so I think you can do all of these with factorizing, but obviously you could use completing the square or quadratic formulas for slightly trickier ones, but I'm keeping the solving part pretty simple for these videos. Okay, so for this first one, we'll think about what it's going to look like. Hopefully you've paused the video and answered these yourself. We've got x squared minus 5x minus 14 is equal to 0. When you factorize this, it's going to be a plus 7 and a minus 2. So the roots are going to be 2 and minus 7. So when you draw that sketch, you're going to have a 2 and a minus 7. Look at how I'm not that bothered about where they are. It's just a sketch to help us think about it. And we want it to be greater than or equal to 0. So we're talking about the branches that are above, which is going to correspond to those green sections. So the solutions are that x is greater than or equal to 2, or x is less than or equal to minus 7. Now this one that we've got here needs a little bit of rearranging first of all. So it's going to be x squared plus 2x minus 8 is less than 0. Of course we can make that become equal to 0. I'm also going to factorize it at the same time as x plus 4 and x minus 2. So the roots are going to be 2 and minus 4. A quick sketch, we're going to say 2 and minus 4. We're talking about the parts which are less than 0, so that's this part, which is the in-between. And so the in-between, the solution to this is that it is in between minus 4 and 2. So our answers are this part and this part that we've got here. And as always, you can pick a value between minus 4 and 2 and substitute into both sides and see if it works. And that way you feel confident that you've got the inequalities the right way round. So in the next video, I'm going to do some further examples, which are perhaps a little bit trickier. If you check in the description though, I'm going to be linking some extra questions that you can do to help you with these. Found this video helpful? Then why not drop it a like and consider subscribing to my channel. If you'd like the next video in the playlist, you can click here to be taken straight to it. And as always, wishing you the very best for all your studies.